Hello viewers, welcome to another episode of our maths class. Today we shall be looking at the topic which says calculus. Calculus is the study of continuous change of a function or rate of change of a function. Calculus is the study of continuous change of a function or rate of change of a function. The two main branches are differential calculus, otherwise known as differentiation. And the other one is integral calculus, known as integration. Okay, for the purpose of this class, we shall be taking differentiation. Differentiation is the rate of change of one quantity with respect to another. Differentiation is the rate of change of one quantity with respect to another. That is to say, if we have one parameter or one quantity or one variable, the rate of change of that parameter with respect to another quantity, parameter or variable is what we refer to as differentiation. When we study the two rates, whether it is rapid or slow, okay? So what helps us to ascertain the rate is differentiation. So therefore, let us have two quantities, y and x, as expressed as y, a function of x. If we differentiate y with respect to x, it will be dy over dx equal to f prime of x. That's what we're going to get. Similarly to this, if we have two parameters, let's say k and l, that is to say k expressed as a function of l, k expressed as a function of l. So if we differentiate the k with respect to what? The l, we are going to get f prime of l. Alright? The various symbols for designating differentiation is delta, which can be change L and D or this. So these are the various symbols used in differential calculus. Alright. Having not done this, we are going to list out the various methods that we need to solve any differential problem. For example, the methods are 1. General method, otherwise known as power method. Okay? Number 2 is the one we call the first principle method. Number 3 is what we know as the chain rule. Also known as function of a function or function of several functions. Okay, number 4 is one we call product rule. 5 is the quotient rule. And 6 is implicit differentiation. Okay, so we'll be taking these methods one after the other: the general method or power method, the first principle method, the chain rule, product rule, quotient rule, and implicit differentiation. So general method of differentiation. What is the idea behind this general method? The idea behind this general method is as simple as that. Let's have our function as y equal to x raised to the power a. Okay? The idea here is if you differentiate y with respect to x, this power a will multiply the base x and 1 will be subtracted from the same power a. So it will be dy over dx equal to the a times x raised to the power a. Subtract 1 from the power. So when we differentiate this, we're now going to have dy dx equal to ax raised to the power a minus 1. Apply it in a practical example. Okay? Example. Solve the following using general method. Solve the following using general method of differentiation. Want to solve this using general method of differentiation. Okay. One says y expressed as a function, let's say a function of x raised to the power 4. Y is x raised to the power 4, okay? And 2, we have a polynomial function y equal to 5x raised to the power 4 plus 2x raised to the power 3 plus x raised to the power 2 minus 2x plus 6. This is the examples that we're going to solve using general method of differentiation. So let us start. Solution 1. It says y expressed as a function of x raised to the power 4. Okay, using general method, you know the idea. Use the power to multiply the base and subtract 1 from the power. So this gives us 4 times the base x raised to the power 4. Subtract 1 from the power. So we're going to get 4x raised to the power 3. And this becomes our answer for question number 1. Alright, let's leave this part of the board and continue our solving. Okay, for number 2, we have a polynomial function which says y is equal to 5x raised to the power 4 plus 2x raised to the power 3. Okay, see it, x raised to the power 2 minus 2x plus 6. Alright, you can see it, what we have here, 5x raised to the power 4, 2x raised to the power 3, x raised to the power 2 minus 2x plus 6. Okay, alright, the answer of this is 4x raised to the power 3, that is our dy over dx is 4x raised to the power 3. So this is the final answer. So number 2 is what we are doing over here. To differentiate this with respect to x, it will be dy over dx. Remember the idea that the power will multiply the base. Our base here is not only x, our base is 5x. So it will be 4 times 5x raised to the power 4 minus 1 from the power. Put your plus sign. Second one is 3 times 2x. Make the multiplication to be bold so that it will not clash. So we have 3 times 2x raised to the power 3 minus 1. And this one is 2 plus, the power is 2. Say 2 times x raised to the power 2 minus 1 from the power. Bring your minus sign. We have this. The power here is 1. So it will be 1 times the base 2x raised to the power 1 minus 1. And finally, we differentiate a constant, you have 0. Why is it so? Let's assume that this 6 is multiplying x raised to the power 0. And we know that any number raised to the power 0 is 1. So it will be 6 times 1, 6, because the power is 0. So with the idea of general method, we are going to use this 0 to multiply everything whenever you get it. So when you use 0 to, and any number multiplied by 0 will actually give us 0. So when we differentiate a constant, we have 0. So having reached this far, our dy over the x will be, come over to this place, 4 times 5 is 20, I have 20, x raised to the power 4 minus 1 is 3, plus 3 times 2 is 6, x raised to 3 minus 1 is 2, plus 2 times x is what? 2x, 2 minus 1 is 1, so there's no need to write it here. Then here, 1 minus 1 will give us 0. X raised to the power 0 is 1, 2 times 1, 2. So if we differentiate these two x, we are likely going to have minus 2. And when we differentiate 6, we have 0, so there's no need. As after the differentiation, so our answer becomes 20x cubed plus 6x squared plus 2x minus 2. Okay, that is the idea behind the general method. Next method we shall be looking at is the first principle method. The first principle method of differentiation. So let us look at what first principle method of differentiation is all about. Okay, first principle method. For example, we have y equal to x. Write this very well. Y equal to x. The idea behind first principle is to every y add changing y, and to every x add changing x. So this will now be y plus changing y equal to x plus changing x. Okay, you can work on this. Remember that if we differentiate x, we have 1. If you want to know what we're talking about, if you differentiate using general method, if we differentiate this using general method, let's say y equal to x, then the y over the x will be, this is x raised to the power 1 minus 1, right? Which will be 1 times this. We have x raised to the power 1 minus 1 is 0, so we are going to have 1 times x raised to the power 0, which is 1 times 1. To give us 0. So if we differentiate x, you have 1. Let's use the first principle method and know if it will give us 1. Okay, having known that differentiation of this gives us 1, let's use first principle method. Remember that I said the idea behind the first principle method is to y add changing y and to x add changing x. So having done this, we transpose this over here. We are going to get change in y equal to x plus change in x. Okay, minus y. Recall that y here is equal to x. So any place we see this y, remove it and put x. Alright, we continue from this part of the board. Continue from this part to finish up that work on first principle method of differentiation. Okay, so this will give us a change in y equal to x plus change in x minus, instead of writing this, I'll put x. So x cancels what x. We are left with change in y equal to change in x. Divide through. Divide true by change in x. When we divide true by change in x, we have change in y equal to change in x. This over change in x over change in x. This cancel 1, 1. So our change in y over change in x equal to 1. So this actually gave us the same answer we obtained when using the general method. So before we wrap up this session, let us take one more example on first principle method of differentiation. We call that number 2 and we call this number 1. Alright, number 2 says y equal to x squared. We have this to solve using first principle method of differentiation. So remember the idea behind this. So every y add change in y, so this will be y plus change in y and equal to x plus change in x all squared. Okay, having gotten this far, what we are going to look out for is to expand this bracket. And when we expand it, we have y plus change in y equal to x squared plus 2x change in x plus change in x squared. So that's what we are going to obtain if we expand the bracket. For some of us that did not understand what I did, I will explain so that you get it better. So that you use the Pascal's triangle or we expand. I will normally do so. Let us keep this aside and show our friends how we obtain this. Remember that x plus change in x is squared, right? If you separate them, it will be x plus change in x multiplied by x plus change in x. That's what it means. So having reached here, let us multiply and get this. Okay? So we have to do that over here. Now it will be x, multiplying everything here, x multiply x plus change in x, and plus change in x multiply x plus change in x. So x times x is x squared, x times this will give us plus x change in x, this time this will give us plus x change in x, this time this will give us change in x squared. So we have similar term here, it will be x squared plus 2x change in x plus change in x squared. Okay, if you watch this, you will see that it's exactly what I have here. So that is how I obtain this. Having not done this, we continue with our solving using first principle method of differentiation. So having ascertained how this came about, we continue. So next is to transpose this y over here. And when that happens, we have change in y equal to x squared plus 2x change in x plus changing x squared minus y. Recall that y is equal to what? X squared. So I'm going to replace this y here with x squared. Therefore, my changing y equal to x squared plus 2x changing x plus changing x squared minus x squared being replaced by this. So x squared goes. We are left with changing y equal to 2x changing x plus changing x squared. Divide through by changing x. So this will give us changing y equal to 2x changing x plus changing x squared. So divide that by changing x. This do separately changing x and changing x. So this cancel this cancel this too. Then we have our changing y over changing x to be. We have our changing y over changing x to be what? 2x plus changing x. So remove this changing x. Take limits of changing x as it tends to 0. So this will now be changing y over changing x as the limit of x tends towards 0. So this will be 2x plus this changing x tends to 0. When the multiply it becomes 0. So our change in y over changing x will now be 2x with the limit of changing x tends towards 0. So we have our answer. You can see it now. Using the first principle method, we obtain that our answer is 2x. Everyone can see it. Then if we use the method of power method, we can still get it. So this is where we mark the end of our class today. But I'm not going to leave you empty-handed. I'm going to give you a task to do. After solving, you can write the answer for me in the comment section. So I have a task for you, and it is thus. Assignment. Okay. Using general method and first principle method. First principle method. Okay. Comma, solve y equal to x raised to power 3. So this is the assignment. Alright. Thank you, my wonderful viewers. This marks the end of our class today. Do me a favor to subscribe to my channel, share this video, let it go viral, and moreover, click the like button for me. Remain blessed. Bye for now.